Some problems we can't factor and we can't use our square root method on to try and solve them, so we're going to need to turn to the quadratic formula to be able to solve them. Now the nice thing about the quadratic formula is it will work for any type of quadratic equation that you have that is set equal to 0. So the way we're going to use this is we're going to solve this for any quadratic of the form ax squared plus bx plus c equals 0. And all we have to do here is plug in the coefficients of each of these terms into the formula, and it should come up with our two answers for x. Now, if it's something like this one that will not factor, it's gonna be probably pretty ugly when you get your answer. If it is something that would have factored, it might come out to be a nice even number like x equals 5 or x equals -2. Okay, but for most of these, not all, we're going to have two answers. They could be real or imaginary, and we'll kind of talk about this as we go. So if we look at this first example, what I'm going to do is just to hold the place here, I'm going to put a 1 in front of my x squared term, and then we can look at the a, the b, and the c in this formula. So let's go ahead and start plugging things in here. So we've got that our x, if we solve this, then x will equal, this first part here says the opposite of b. So if you look at b here, b is -2. The opposite of b is going to be +2. Okay, so whatever sign you have, it's just going to be the opposite sign. Plus or minus, that means we're going to probably end up with two answers here. The square root of b squared minus 4ac. Okay, so what I'm going to do is punch in, and notice that I have this in parentheses. The b is -2 minus, excuse me, I'm getting ahead of myself here. That should be a -2. I'm going to that 4 a little too early. Minus 4 times a, which is 1, times c, which is, don't forget that negative sign, -1. So that whole -1 is c. And that's all going to be divided by 2a. 2 times 1. Now, what we're going to, this looks really ugly, but I promise you that it won't be too bad to simplify. What I like to do is actually just evaluate this part first. So whatever's under that radical, that b squared minus 4ac, I like to evaluate that first. That's actually called the discriminant, and it helps us kind of get an idea of what our solution is going to look like. Now, you need to be very careful on this step. If you square -2 in parentheses, it's not -4, it should be +4. So it should be 4 minus, if we have -4 times 1 times -1, these two negative signs here will cancel and make this a +4. So 4 plus 4. What I do is I personally punch that whole thing. If your teacher lets you use calculators, I would punch that whole yellow thing into your calculator. Just don't forget parentheses around the -2 when you square it. So we'll do 4 plus 4, and we'll do 2 plus or minus this, all divided by 2. So I just starting to simplify the inside. Now 4 plus 4 we can reduce to 8, so we'll get x is equal to 2 plus or minus the square root of 8, all divided by 2. Now in this step, I'm actually going to break this up into two separate square roots, so, or excuse me, two separate fractions. So I'm going to write this as 2 over 2 plus or minus. I'm also going to reduce this now too. I'm going to reduce the square root of 8, and that will reduce, if I kind of split this up here, into the square root of 4 times the square root of 2. 4 is a perfect square, so that reduces to 2 root 2. So I'm just going to rewrite 8 as 2 root 2, and I'm going to also split that over 2 as well. So I just broke this into two fractions and reduced the radical there. And now we're almost there. All I have to do is reduce this fraction. 2 over 2 is just 1, plus or minus. And then these 2's would cancel here, and that'll give me root 2. So we know that the solution to this equation would be 1 plus root 2, and also 1 minus root 2. Since these won't combine, I can leave them in that form, but if you ever get an answer of like 5 plus or minus like 7, you'll want to actually do the two solutions of 5 plus 7, and then 5 minus 7, which would give you, 12 and -2. So if they do combine them, but in this case, since these radicals and these numbers are not like terms, they won't combine. So that's all we can do for that one. If you want a decimal approximation of what that would be, you just type 1 plus root 2 and 1 minus root 2 in your calculator. 1 plus root 2 would give you about 2.4-ish, and then 1 minus root 2 should give us about negative 0.4. And that gives you an idea of about where those would be if you're looking for x-intercepts on a parabola, which you may or may not be to yet. Okay, we're going to go through one more here and just kind of setting things up. So if we look again, we've got the opposite of b. So this in this case, the opposite of negative 2 would be positive 2. So we'll have x equals 2 plus or minus. Again, I'm going to square this right away. So this negative 2 squared, I'm just going to put in here as 4 just to make my life easy. I like to just square that so I don't worry about that negative sign. Minus 4 times a times c. And if we kind of keep going here, so we'll have on the bottom, oops, all over 2a, so that's 2 times 2. So we still keep going here, x equals, and now if we go in here, 4 minus 4 times 2 times 3, again, you can just either punch that whole thing in your calculator, or if you want to do that step by step, you can, but this should be negative 20 in here, so that's negative, or that's 24, 4 minus 24 is negative 20, and then on the bottom, we're going to have a 4 here. So that gives me x is equal to 2, and I'm going to split it into two fractions now, plus or minus. Now, you might notice here that we've got a negative under the radical, and when that happens, we're going to end up with actually two answers that are imaginary numbers. So let's kind of reduce this here. This will give me negative 4 times 5 is the biggest square root, and sorry that the cat is jumping on the computer and screaming while I'm trying to do this here. But if we square root each of these pieces, the square root of negative 4 is 2i, and the square root of 5 we can't simplify, so we'll leave that here. So I'm going to go ahead and rewrite this as 2i root 5 over 4. And then finally, if we reduce these two fractions, 2 over 4 should reduce to 1/2. And this 2 over 4 should also reduce to 1/2. So 1/2 plus or minus 1 over 2. And then, excuse me, let's get rid of that 1. We don't really need that up there. We'll just do I over 2. So we'll do I over 2 root 5. And we'll sneak the root 5 up top there. So you can see that again, if you have a negative square root inside this discriminant part, so if this discriminant part is negative, that means you're going to have two imaginary solutions. If the discriminant is positive, you're going to have two real solutions, kind of like we did in this last example here, where that turned out to be a positive 8. We had two real solution answers. And if the discriminant is 0, you actually have something called double root, where you only have one solution. Okay, so that's just a quick introduction. And again, the discriminant is this inside part here, and it just kind of gives you an idea of what your solutions look like, what kind of x-intercepts you would have if you're looking at something like a parabola. So that's a quick introduction to the quadratic formula. You can use it on any problem that has the form ax squared plus bx plus c equals 0. It's especially useful for problems that won't factor because there's no real other good method that we have to solve those. Unless you're doing that take the square root of both sides type of problem. And then make sure that, again, when you're using this, you got to get everything equal to 0 first before you use the quadratic formula.